Solving a right triangle means that we would like to find the measures of all of the angles and all of the sides of a given triangle. We'll start out by drawing a picture of our triangle. So we're asked to solve the right triangle ABC if B equals 28 degrees and 40 minutes and A is 25.3 centimeters. Let's start by drawing our triangle. It's a right triangle, and traditionally C represents our right angle, and we'll call the other angles capital A and capital B. And we know that B is 28 degrees and 40 minutes. Go ahead and label that. And we are given that side A is 25.3 centimeters. And this would be side A, so we'll call that 25.3 centimeters. And side B would be across from angle B, and side C is across from angle C. So we are asked to find angle A. We need to find sides B and sides C. Now, finding the angle A is easy. 90-degree angle is our angle C, that's our right angle. B, we already know that. And we know that when we add up our angles, A plus 90 degrees plus angle B, 28 degrees and 40 minutes, that the total has to be 180 degrees. So let's solve that for angle A. So 90 plus 28 degrees and 40 minutes. Let's see, that would be 118 degrees and 40 minutes. And then subtract 118 degrees 40 minutes from both sides. Oops. So A equals, and we'll have to borrow, so we'll call this 179 degrees and 60 minutes. And that leaves us with 20 minutes and 61 degrees. So 61 degrees and 20 minutes would be the measure of angle A. Now what about sides B and sides C? Well, in order for us to use the Pythagorean Theorem, we have to know two sides, but we only know the length of one. So here we're going to have to solve what we call a trig equation. So working from the angle that we know, that we were given, working from the perspective of angle B, let's form a trig equation based upon one of our trig definitions that involves A, the side we know, so we want to involve side A, and let's say side B, one of the sides that we don't know. It doesn't matter if you were working with side C or side B, but we want to set up a trig equation that has only one unknown. So if I'm working with angle B, and I want to work with sides A and B, well, side B would be opposite, side A would be adjacent. So opposite and adjacent, that sounds like tangent. So tangent of angle B would be equal to opposite over adjacent. We're going to set up our trig equation. We know angle B is 28 degrees 40 minutes. We know that equals to opposite over adjacent, so side B, well, I don't know side B, but I do know side A, 25.3. So we have a trig equation with only one unknown. Now we can solve for that one unknown. We can solve for angle B, or side B. So we're going to solve, get B by itself. We're going to multiply both sides by 25.3. That way it cancels out here, and I'm left with B is equal to, and we're going to type this into our calculator, 25.3 times tangent, 28 plus 40 divided by 60, just like we talked about in section 2.3. and I get 13.832222071. We're going to round to the nearest tenth, because that's what the other side is rounded to. So the nearest one decimal place, our side B then would be 13.8 centimeters. So we can solve for side B using a trig equation that involves only one unknown. Once we have solved for side B, 13.8 centimeters, now we can solve for side C. Now solving for side C will be a little bit easier because we already know two sides and we can use our Pythagorean theorem now. A squared plus b squared is equal to c squared. Okay, we could just put this into our calculator exactly as we have it. 25.3 squared plus 13.8 squared. Set enter. We get 830.53 is equal to c squared, and now we need to take the square root of both sides, and all we have to do is put that into our calculator, and I get 28.8189, etc. And we're going to once again solve to the nearest tenth, which makes our answer for C to be 28.8 centimeters. Example 2, we want to solve the right triangle ABC if side A is equal to 18.9 centimeters and side C is equal to 46.3 centimeters. Let's start by drawing a right triangle, and we're going to label this as angle C. Let's call that angle A, angle B, and then our sides A, B, and C. So we're told that side A is 18.9 centimeters. So we'll go ahead and label that. And side C is 46.3 centimeters. Now this time it's going to be easy to determine our side B. So let's see what we're looking for. We're looking for side B, we're looking for angle A, and also for angle B. Those are the three unknowns. So this time it'll be easy to solve for the third side because we already know two of the sides. We're solving a squared plus b squared is equal to c squared. So we know that a is 18.9 squared plus b squared, we don't know that one, is equal to 46.3 squared. So we're going to subtract from both sides 18.9 squared. So we know that b squared is equal to 46.3 squared minus 18.9 squared. We're going to put that into our calculator as we have it. 46.3 squared minus 18.9 squared, and we get that b squared is equal to 1786.48, and we are going to take the square root of both sides. Once again, we'll just let our calculator take care of that. And we get that b is equal to 42.2667. We're going to round to the nearest tenth again. So that means that the 6 will put b to be 42.3 centimeters. So we know two of the sides. We could find the third one very easily using our Pythagorean theorem. Now we are looking for angles A and angle B. We already know that angle C is 90 degrees, so we need to find the other two angles. Okay, let's find angle A. And we're going to find angle A using the sides that we were given at the beginning. So for angle A, the sides we knew would be the opposite side and the hypotenuse. And opposite and hypotenuse deal with sine. So we're going to set up a trig equation based upon the angle that we want to find and two sides that we already know, A and C. So sine of angle A is equal to 18.9 divided by 46.3. And we're going to put this into our calculator. We're going to use the inverse function. This time we want to find the angle, and the inverse function is what we use to find angles. We're going to put this into our calculator. We're going to hit the second button, or shift. In your calculator you should see sine with a -1 at the top, and then in the parentheses we're going to put 18.9 divided by 46.3. And we get that angle A is 24.0927. We're going to round here. Let's round to the nearest 2 decimal places. So that gives us 24.09 degrees. Now that we know 2 of our angles, to find the third one, it's going to be very easy. We have 180 degrees to begin with. We can subtract off 90 degrees for our angle C. That leaves us with 90 degrees left over. And now we can subtract from that angle A, 24 degrees and 24.09 degrees. And we just put that into our calculator, and our calculator gives us 65.91 degrees for angle B. So once we know 2 of anything, the third one is always very easy to find. Now for example 3, we're asked to solve the right triangle, and this time we're actually provided with a picture. We know angle B and angle C, and we know side B. What we're looking for now is what is the measure of angle A, what is the measure of side A, and what is the measure of side C. So these are the 3 things that we are going to try to find. And let's first find angle A. Since we know 2 angles, the third angle is very easy to find. So we can say 180 degrees, take away 90, that's for our angle C, we're left with 90. And now we can subtract off from that 45 degrees and a little bit more there. We're just going to let our calculator do that work for us. And I get 44.9107 degrees. So our angle A, and we'll just leave it rounded to the nearest 4 decimal places. So there's my angle A. So anytime I know 2 of something, the third one is very easy to find. So now I'm looking for sides A and side C. Okay, we're going to start with the angle B that we know, and we're going to involve the side B that we know. So we have 2 things that we know, and we're going to include with this a side that we don't know. Let's say that we include side C. Well, this would be opposite, and this would be the hypotenuse. So if I'm going to set up a trig equation with 1 unknown and 2 knowns, then we're going to recognize that opposite over hypotenuse would be sine for angle B. So sine of angle B would be side B divided by side C. We're going to fill in our knowns. So we have sine of 45.0893 degrees is equal to side B, so that would be 56.853 divided by side C. That's the side I don't know. Okay, now we can solve for c, we can multiply both sides by c. And then, once we multiply both sides by c, then we can divide both sides by sine to get c by itself. So now, what we have is c is equal to 56.853 divided by sine 45.0893 degrees. And all we have to do is put that into our calculator, and I get 80.27726 and so on. And since our side is rounded to the nearest 3 decimal places, we'll do the same thing for side C. Now we know 2 sides, and now we can find the third side by using our Pythagorean theorem. So we have a squared plus b squared is equal to c squared. We don't know side A yet, so we'll leave that as a squared. Our b squared, our b is 56.853 equals c squared, and we just solved for c, and we wrote it as 80.277, and we will square that. And of course we can let our calculator do this work for us. I'm going to subtract 56.853 squared from both sides. So I get a squared is equal to, I'm just going to type this directly into my calculator, and I get that a squared is equal to 3,212.13312. And of course, to solve for a, I need to take the square root of both sides. And we're going to round to the nearest 3 decimal places again. And that would round up to 56.676 centimeters.